Alrighty, lesson 13. We are continuing our unit 2 journey, now talking about systems of linear equations. We talked about what systems of linear equations were last lesson and how to find them using graphs. Today we are going to talk about one algebraic way of solving systems of linear equations. As we move forward between this lesson and next lesson, I do not care how you choose to solve your systems of equations. If you have a strategy that works for you, I wholeheartedly will let you graph or use a table or use this algebraic systems using substitution. But today I'm going to introduce you what it means to solve a system using substitution. So that is our learning objective for today. You can use substitution to solve systems of linear equations. Vocabulary, what does substitution mean? Especially think about the method itself. And like terms, combining like terms is something you should have been doing before you've come to this class, but I just want to remind you what it means what like terms represent and how to combine them. So those are two of our vocab words today. And so today you're going to start off with a math talk talking about, all right, think about graphing, right? These represent systems of linear equations, right? These could represent a system of linear equations. And can any of these represent the two lines that are being graphed right now? Think about the red and the blue. Think about strategies that we talked about last class and how you can connect them to our solution working with our discussion today. And so today we talk about what it means to use substitution to solve systems of equations. And so what we can see here is that we have a system of linear equations, right? We have two equations. And how can we use substitution to help us find our solutions? And so in this instance, right, we start off with something a little simple, right? We have 3x equals 8 and 3x plus y equals 15. Remember, when we want to find our solutions, I want to find out something like x equals blank, x equals something, and some sort of y equals something else, right? That is my goal. I want to find a pair of solutions. We talked about representing that using coordinate pairs like we did yesterday when it came to our graphs, but you can also write it as x equals and y equals. And so when it comes to this system, I can pretty simply solve for x, right? If I have 3x equals 8, but operation, I want to isolate my variable. So if I want to isolate my variable, I want to divide by 3 on both sides because I see multiplication here. Think about your operations and your inverse operations, right? So I have divide by 3 on both sides because I want to isolate x. And I can see that here x equals 8 over 3. Now that I know x equals 8 over 3, I need to figure out what y is. And so that's where I look at my second equation. If x equals 8 over 3, then I can substitute that back into my equation, right? I'll put it down here, change the color, right? So I can substitute that back in where I have 3 multiplied by 8 times 3, right? That's what replaces x. We're substituting it in, plus y equals 15. 3 times 8 over 3 just gives me 8, plus y equals 15. I want to isolate y. And so to do that, I need to subtract by 8 on both sides because I see addition. I need to do the opposite operation of subtraction. Subtract by 8 on both sides. And that gives me y equals 7. And so my solution to my system of equations is x equals 8 over 3 and y equals 7. And I can check that by substituting it back into my equation, to both of my equations. I know that if x equals 8 over 3, then substituting x back in, 3 times x over 3 gives me 8. This equals 8, which is perfect, exactly what I'm looking for. Into my second equation, I have 3 times 8 over 3 plus what my y is, y equals 7 equals 15. 3 times 8 over 3 is 8 plus 7 equals 15. 8 plus 7 is 15, which equals 15, and everything is good. Remember, the pair of equations is a solution to both of your equations. That is why we call it a solution to the system of equations. Both that pair, that solution, x equals something, y equals something, should be a solution to both of your equations. So when you're checking your answer and something goes wrong, go back and check your math, right? Something might be wrong. And so it might start to get a bit complicated when you don't have a equation with only one variable. And so you'll see here now, okay, I have two variables, but I have something that is y equals. And so instead of knowing exactly what x is before I substitute in, I can take my solution and substitute that in. If I know that y equals 2x minus 7, I can replace that for y in my second equation, right? I can say 4 plus 2x minus 7 equals 12 because this entire thing equals y. And you can find easier ways to solve this too. There's another way of solving this system that I just wrote down, circled in light blue, right? See if there's an easier way to solve it. And so this is just practice continually solving our equation. But don't forget that your solution is a solution to both of your equations in your system. So if something doesn't work out when you're checking your answer, then you know to go back and see whether you did an algebraic mistake or you did some sort of small computation mistake. And so I want you to continue to practice that when it comes to 3.3, right? You are given a bunch of solutions and you're given a bunch of systems of equations. You can go about this two ways. You can go solving the systems of equations and finding the solution, or since you're given solutions, you can substitute the solutions back into the equation and see if those represent solutions to that equation, right? I can substitute in x in for that's supposed to be a y, right? X into our equation and y into our equation and see what happens. And last but not least, we'll talk about some of the strategies you use. You don't necessarily have to use substitution. So see what strategies you use to solve the system of linear equations. Last but not least, we have the summary talking about an example of systems of linear equations and what you can do to find your solution, some of the strategies and operations you can use. I will see you in lesson 14.